The DJI Power 2000 is the company's first large capacity power station, stepping up from their smaller Power 500 and the recently released Power 1000 V2. These are essentially high capacity battery packs with built-in AC plug sockets, USB and DC outputs, designed to power everything from laptops and fridges to tools and lighting, whether you're off-grid, in a camper van or dealing with a home power cut. While DJI is best known for its drones, the company has years of experience with battery technology, so it makes sense they're now applying that expertise to portable power. The Power 2000 goes up against one of the most established models in this category, the EcoFlow Delta 2 Max. Both use long-lasting 2048 Wh LFP batteries, but there are some important differences in design, performance and features. I've tested them side by side, charging speed, AC and DC output, UPS and USB capabilities and more to help you decide which one's right for you. So let's take a look. The DJI comes boxed with just an AC charging cable. The EcoFlow comes with an AC charging cable, a car charging cable and a DC 5521 to DC 5525 DC cable. They're similar in size, you can see their dimensions on screen. But the EcoFlow weighs over a kilogram more than the DJI, coming in at 23.4 kilograms versus 21.8 kilograms for the DJI. They both really need two hands to move them around and are approaching the limit of what I call portable. The DJI does feel a little more manageable. The EcoFlow has its display and USB ports around the front, and its mains and solar charging inputs and AC and DC outlets around the back. This makes sense in certain scenarios, but I tend to prefer DJI's design with everything on the front. I find it makes it easier to use. The build quality of both units is excellent, although neither has any weatherproof rating. It comes down to personal preference, but I do prefer the slightly more modern design of the DJI. The DJI has just two buttons. A long press of the power button turns it on and off. A short press with the power station turned on toggles the display. The display is large and clear. I find it easier to read compared to EcoFlows, especially outside. There's also the AC button, which turns on the inverter and its AC outlets with a short press. A short press of the power button turns on the EcoFlow and toggles the display. A long press turns it off. The display on the EcoFlow is a little smaller than the DJI, but it's still clear and bright. There is a power button for the USB ports around the front and power buttons for both the AC and DC outputs around the back. Here in the UK, both units can charge via mains at up to 10 amps, which at 240 volts is an impressive 2,400 watts. The DJI has a switch next to the AC input to set charging speed. The top fast recharge mode position for full speed and the lower standard recharge mode position for more battery friendly and quieter, slower 1200 watt charging speed, but this can't be configured. The EcoFlow also has a charge speed switch and the slow position is configurable in the app from 200 watts to 2400 watts in 100 watt increments. I recharged both power stations from completely empty at full speed, making sure they were both completely cooled down before starting the tests. EcoFlow claims 53 minutes for an 80% charge and 80 minutes for a full charge, which in my tests were pretty much spot on. The DJI Power 2000 reached 80% in just over 51 minutes, not quite 45 minutes that DJI specify, but faster than the EcoFlow. It was fully charged in just under 1 hour 8 minutes, which is 7 minutes faster than DJI specifications. I checked noise levels charging both units at full speed. They are both very quiet. I measured around 45 decibels 1 metre away for both the DJI and EcoFlow. Background noise was around 37.5 decibels. I also checked the thermals charging at full speed. Neither got too hot. The DJI got to around 46 Celsius and the EcoFlow ran very slightly cooler at around 43 Celsius. The DJI can charge from a car's 12 volt outlet, although you'll need an additional accessory from DJI that plugs into one of the unit's two proprietary SDC ports. These SDC ports are incredibly flexible. They expand the capabilities of the power station with an assortment of dongles which can adjust both voltage and current in or out. This car charging dongle has 12 to 30 volt input at up to 8 amps, but with a 100 watt maximum output, which does mean it can't take full advantage of a 24 volt car outlet. Charging off a standard 12 volt car outlet in my VW campervan, the power station charges at 100 watts. A full charge would take at least 20 hours. My van has two 12 volt outputs, so you could use two of these car adapters for faster 200 watt charging. I didn't have another car adapter, but use the solar charger I'll cover further shortly, which accepts up to 3 inputs. Using both 12 volt car outlets, I got around 250 watts with this accessory. This would also work with a 24 volt car outlet if your car has that, which I confirmed in my bench power supply. The EcoFlow is supplied with a car charging cable that plugs into one of the 2 integrated XT60 ports. These ports both have an 11 to 60 volt input at up to 8 amps for car charging, so can support both 12 volt and 24 volt car outlets. I got just over 100 watts with one 12 volt output and just over 200 watts when connecting both car outlets to the 2 XT60 inputs. Both units support solar charging, but again the DJI requires an additional accessory. It doesn't have a built-in MPPT controller to regulate the variable voltage from solar panels. DJI currently offers 3 accessories that allow you to connect solar panels to their power station. The car charging dongle we just tested will work with a single panel under 30 volts. Just remove the car charger to XT60 component. I tested it with a folding Xigness 120 watt panel from DJI, which already has an XT60 connection which plugs straight into the remaining portion of the charging accessory. On a sunny day in mid-July, I still only got around 80 watts with this setup, which isn't really enough for a unit like this. You could add a second panel with another car adapter into the second SDC port, but you're better off getting DJI's solar panel adapter I briefly mentioned under car charging, which has 3 XT60 ports. It's still a little limited in that it only supports 12 to 30 volt panels, so it wouldn't run my larger 350 watt Bluetti PV350 panel that runs at over 30 volts. But I was able to run both the Xigness 120 watt and my 200 watt Bluetti PV200 panel simultaneously, reaching a combined input of just over 240 watts. The solar panel adapter has a maximum of 10 amps 200 watts per port and a 20 amp 400 watt maximum overall. With another 120 watt or 200 watt panel I could have reached that maximum. I did manage to simulate this maximum input using 2 bench power supplies. You could also add another solar panel adapter into the second port for a total of 800 watts. But DJI also does their 1.8 kilowatt solar car supercharger. I haven't tested this yet, but it supports up to 1200 watts of solar and can also charge your car's battery at up to 600 watts. Its solar inputs are far more flexible too, at 12 to 60 volts at up to 20 amps, so it supports larger panels, or you could connect smaller panels in series. It is pretty expensive though. Which brings me to the EcoFlow. The Delta 2 Max has an integrated MPPT controller and a very capable one at that. Its 2 standard XT60 inputs each support 11 to 60 volts at 15 amps with a maximum total output of 1000 watts, 500 watts from each port. I got over 300 watts connecting just a single larger Bluetti 350 watt panel into one of the inputs. I only had one MC4 to XT60 adapter, so couldn't add the PV200, but with both the PV200 and Xigness panels connected, I was getting a similar output to what I saw with the DJI Power 2000. With my bench power supplies, I could simulate over 600 watts of solar. I could have got more, but my test leads have standard XT60 connectors, so EcoFlow assumes a car is supplying power and limits the input to 8 amps. You can only get the full 15 amps intended for solar with XT60i connectors, which have an additional pin. Let's look at the performance of the power stations, starting with the AC outlets. The DJI has 4 3000 watt AC outlets. The EcoFlow has 4 2400 watt AC outlets. All outlets have a pure sine wave output important for sensitive electronics, which I confirmed with the graphical multimeter. In the EcoFlow app, you can turn on X Boost, which lets you power purely resistive loads like heaters and hairdryers at up to 3100 watts. It does this by lowering the voltage, so use this mode with care. Both these power stations can run pretty much anything with a plug. To test them to their limits, I started off with a kettle. The EcoFlow is rated at 2400 watts continuously, but managed to almost boil a full kettle at over 2600 watts until it overloaded the inverter after over 2 minutes. Adding in a variable load, I ramped it up to see the maximum it could achieve for a short burst. It got to almost 3000 watts, which is impressive. The DJI is the most powerful power station I've tested so far, rated at 3000 watts. That's at the limit of any device you can plug into our UK sockets with a 13 amp fuse. It had no trouble boiling the kettle continuously at 2600 watts, or 3000 watts for that matter, with the additional load attached. Ramping up the variable load, it finally cut out at over 3300 watts, so you could run pretty much anything off this, from a 4-slot toaster to an induction hob or a coffee machine. The EcoFlow isn't far off, but it's nice having almost no limitations and being able to plug in multiple high-power devices simultaneously. To really challenge both units, I tried running a large 100-litre compressor and a 14-inch bandsaw. Both power stations could run my compressor, which is super useful, but only the DJI could handle the bandsaw. Machinery like this with an induction motor has a very high startup draw, even though their running power is comparatively low. That initial surge proved too much for the EcoFlow. AC inverters can use a fair bit of power even when they have no load attached. Both units let you set a timeout if you accidentally leave them on. But I deliberately set this to never to test their parasitic drain. I charged them both to 100% and then left them for 16 hours with no load attached. The DJI had 84% battery remaining and the EcoFlow had 80% battery remaining. An average result for the EcoFlow and a slightly better than average result for the DJI. With a constant 2 kilowatt resistive load from an electric heater and an energy monitoring plug, I measured the usable capacity of the 2048 watt-hour batteries of both power stations. The DJI ran for just over 55 minutes and used 1843 watt-hours. The EcoFlow ran a fraction longer and used 1901 watt-hours. That's 90% and 93% efficiency respectively, both excellent results. To use a DC output of the DJI, you need another dongle. There's no usually standard 12-volt car outlet. I used both power stations to run my EcoFlow Glacier portable fridge freezer and confirm their maximum 10 amp output with a load tester. I used this setup to measure the usable capacity off DC. I measured 1348 watt-hours off the DJI and 1510 watt-hours off the EcoFlow. The DJI is lower than I'd expect at around 66% efficiency. The EcoFlow fared a little better at 74%. My next test helped explain these results. I measured the parasitic drain of the DC subsystem. On the EcoFlow, I disabled the DC timeout and turned on DC power. The DJI doesn't have a dedicated DC switch, so I simulated an idle DC load by plugging the car outlet adapter into one of the SDC ports with no actual load connected. After 16 hours, the DJI had dropped to 80% charge, while the EcoFlow had only dropped to 97%. The SDC port is a highly flexible system, but that flexibility seems to come at the cost of increased power consumption. EcoFlow has a decent selection of USB ports, 2 standard 12-watt USB-A ports, 2 18-watt fast charge USB-A ports, and 2 100-watt USB-C ports. The fast charge ports support Qualcomm Quick Charge 3.0 at 12 volts 1.5 amps, which I confirmed in my load tester. And I could get the full 200 watts off both USB-C ports simultaneously, charging an Anker power bank at 100 watts and configuring 20 volts at 5 amps or 100 watts using USB power delivery to another load tester. The DJI Power 2000 has the best selection of USB ports I've seen on any power station. 4 24-watt fast charge USB-A ports, 2 140-watt USB-C ports and 2 100-watt USB-C ports. This is the first power station I've tested with 140-watt outputs. For a device that you're likely to have for a good few years, it's great it's built to handle future tech. My MacBook Pro already charges at 100 watts, and 16-inch MacBooks can charge at 140 watts. And I already have portable power packs that can charge at 140 watts too. Just make sure you use quality 140 watt EPR rated cables to achieve the full 140 watts. Here I'm charging my Anker power bank at the full 140 watts, and then adding a load tester configured at 28 volts 5 amps for another 140 watts, totaling 280 watts off just 2 USB-C ports. I confirmed the Qualcomm Quick Charge 3.0 12 volt 2 amp off the USB-A ports too. All the USB ports support pass-through charging, so I can charge the power station and use all the ports at the same time. I've already covered various SDC accessories for input and output, but DJI also offers SDC adapters that directly charge their large drone batteries, specifically the Air, Mavic, Inspire and Matrice series at up to 230 watts. I have their Mini 4 Pro and Neo drones, but unfortunately they don't offer direct charging of their batteries, so I can't test out this feature. I did almost use it as an excuse to get an Air 3S, but I resisted. The SDC port can also be used to connect up to 10 2048 watt-hour expansion batteries, increasing the total capacity to a whopping 22,528 watt-hours. The Delta 2 Max can connect 2 additional 2048 watt-hour batteries via its 2 extra battery ports for a total of 6,144 watt-hours of storage. Both power stations feature an uninterruptible power supply or UPS mode. When AC devices are connected while the units are plugged into mains power, those devices bypass the internal battery and run directly off the mains. If there's a power outage, switch over to battery power occurs almost instantly, within 20 milliseconds on the EcoFlow and an impressive 10 milliseconds on the DJI. I tested this with my desktop computer running an intensive graphics benchmark, and both handle the transition flawlessly. While not fast enough for mission critical servers or equipment requiring zero transfer time, the DJI's 10 millisecond response is the fastest I've seen on a power station, making it suitable for most home electronics and even relatively sensitive devices. Both power stations come with companion smartphone apps that allow you to control and monitor the units. Thanks to their Wi-Fi connectivity, you can even manage them remotely, a particularly useful feature. The DJI app is fairly basic and offers limited customization compared to EcoFlow, but it still covers most essential functions. Both power stations performed exceptionally well, each offering distinct advantages depending on your priorities. The DJI Power 2000 stands out with its exceptional AC performance and forward-looking connectivity, most notably the inclusion of numerous USB ports, including two 140-watt USB-C outputs. This makes it well suited to charging power-hungry laptops and other demanding USB-C devices that are becoming more common. When it comes to AC performance, it ran everything I tested, including a 100-litre compressor and a 14-inch bandsaw. It's the most capable power station I've reviewed to date. The DJI also showed lower parasitic drain when left idle with AC enabled. And DJI's claimed 10 millisecond UPS transition is half that of the EcoFlow, although both units handle a simulated power cut seamlessly. Both power stations are well made, but the DJI has a slightly more modern design, including a larger, clearer display. It's also slightly lighter than the EcoFlow, partly because it lacks an integrated MPPT controller. But this does make it a little more manageable. Both units offer a 5-year warranty, although DJI arguably offers more established after-sale support. The EcoFlow Delta 2 Max is a solid all-rounder, offering more built-in functionality straight out of the box, including dual XT60 solar inputs, a car charging cable, and flexible input support up to 60 volts. It performed better under DC loads and provides greater customization via its app, including adjustable charging speeds. While DJI's SDC system requires external dongles even for basic functions like 12-watt output, the concept is appealing. I'd like to see DJI expand on this with more configurable adapters, ideally ones that allow voltage and current control in-app for tasks like powering a LiPo charger, for instance. Despite the current downsides, extra accessories to manage, and slightly higher DC idle consumption, the SDC ecosystem is powerful and can become a major asset as more adapters are released. I'm planning to 3D scan the Power 2000 itself so I can design a custom storage tray that fits neatly on top, ideal for holding the various SDC dongles and cables. DJI doesn't currently offer anything like this, but if it works well, I'll share the design. So in summary, if you want ultimate output and future-proof connectivity, the DJI Power 2000 is hard to beat. For plug-and-play versatility, the EcoFlow Delta 2 Max remains a great choice. If you found this comparison helpful, please give the video a thumbs up. It really helps the channel. I read every comment and do my best to respond. So if you've got any questions, feedback, or your own experience with either of these power stations, let me know down below. If you'd like to support the channel, you'll find affiliate links to both units down in the description. And if you haven't already, please consider subscribing and tapping the bell. I release new tech videos every week. Thanks for watching.